flight control systems in the F-4 are basically models of simplicity. Yet reports from the field show that they're probably the least understood systems in the airplane. The purpose of this film is to generally acquaint F-4 pilots and ground crews with the operation of the control systems and how to identify and troubleshoot possible malfunctions in the systems. First, let's take a look at the manual, or basic control system. Directional, or yaw control, is provided through a hydraulically powered rudder controlled by a series of push rods, cables, and bell cranks. Using this McDonald training aid, we see that pilot movement of the rudder pedals is transmitted through these push rods, bell cranks, and cables to the rudder power control cylinder, which in turn moves the rudder as much as 30 degrees right or left. It's as simple as that. This hydraulic field cylinder regulates the amount of pressure needed on the rudder pedals to deflect the rudder. At low speeds, where rudder is used more, this field system makes it easier to move the rudder pedals. It is separate from the basic control system linkage. At higher speeds, the pedals are harder to move to reduce the possibility of over-controlling the aircraft. A loss of utility hydraulic pressure will cause high pedal forces, but rudder control still is possible. The neutral or feet-off position of the rudder and the rudder pedals is set by the rudder trim, which moves the whole manual system. Lateral or roll control of the F-4 is equally simple. The system consists of a combination of aileron and spoiler action. One aileron on each wing, which moves 30 degrees down and 1 degree up, and two spoilers on each wing, which move up only through a range of 45 degrees. Like the rudder pedals, the control stick moves a series of push rods and bell cranks to control hydraulic power cylinders. When the aileron on one wing moves down, the spoiler on the other wing moves up. The only force the pilot feels is the compression of the spring cartridges. There's one in each wing, and they always work together. The neutral or hands-off position of the stick and control surfaces, as with the rudder, is set by the trim system. It moves the whole linkage system. This system, like the rudder trim, is separate from the basic linkage. Longitudinal or pitch control in the F-4, like lateral control, features the control stick mechanically and hydraulically connected to the stabilator. Move the stick, and the stabilator moves. The stabilator travels 28 degrees from stop to stop. There's nothing between the stick and the stabilator that will absorb any of the stick motion. As long as the linkage is intact and there is adequate hydraulic pressure, when the stick moves, the stabilator is going to move. The longitudinal field system, like the other field systems, is separate from the basic linkage. It features bob weights, which simply increase the stick force as the G level increases. For example, when the stick is pulled back, creating positive Gs, the bob weights get heavier, making it harder to pull more Gs. Some F-4s have 5-pound bob weights, and some have 3-pounders. When the 5-pound bob weights are raised by moving the stick aft and then released, the stick will go forward at least to neutral. The 3-pounders may not overcome acceptable friction, and the stick may not move forward. Supplementing the bob weights is the bellows system, which artificially creates the feel of speed changes on the control surfaces. This system cannot be felt on the ground since it relies on ram air for its operation. Ram air from a probe on the vertical fin pressurizes the bellows, which in turn introduces a force into the control system. This force will be felt at the stick and can be removed by trimming. While this force tries to pull the stick back, the bob weight is trying to pull it forward. These opposing forces between the two systems can be made to keep the stick in one position by trimming the bellows force to balance the bob weight force. As long as the airspeed stays the same, there will be no force change in the bellows system and no trimming required. But any increase or decrease in speed will change the bellows force and retrimming will be required. Another element of the longitudinal field system is the viscous damper. The damper just makes it a little harder to move the stick at a rapid rate at supersonic speeds. At subsonic speeds, the damper is bottomed out and has no effect on stick forces or aircraft response. For this reason, the viscous damper has been removed on some F-4s. The change in feel is negligible. Contributing to the stability of the F-4 is the stability augmentation or stab-aug system. This electro-hydraulic system does only one thing. It senses airplane motion, then attempts to stop that motion by putting in small opposite control surface movements without moving the stick or rudder pedals. The stab-aug does not steer the aircraft or remove steady-state maneuvers, but attempts to counter airplane motion. In this way, it augments the normal stability of the airplane and smooths out a bumpy ride. Maximum rudder authority of the stab-aug is 5 degrees left or right from the trim position, and this can easily be overcome by pilot input through the manual system. In the roll channel, the stab-aug system counters roll motion by putting in opposite lateral control. Its maximum authority is 7½ degrees of aileron and 11 degrees of spoiler. As in rudder stab-aug, the pilot can always overcome these roll damper inputs through the manual system. The roll stab-aug also cuts out when the pilot takes command and moves the stick laterally. A switch located in the stick grip opens as the force builds up. This should occur before the stick moves laterally to turn off roll aug and roll axis AFCS. The switch force should always be lower than the lateral control breakout to preclude the roll aug AFCS fighting your command to roll. When the stick is released, the roll stab-aug automatically re-engages. With a 3-axis controller, some pilots turn off the roll channel during maneuvering to eliminate unwanted roll damper inputs. At high angles of attack, adverse yaw can be introduced by the roll aug. It senses roll and commands aileron spoiler, which causes adverse yaw. Remember, the amount of aileron spoiler deflection is a function of roll rate, which is low in wing rock. In the pitch channel, the stab-aug authority is limited to only 1/2 degree of stabilator movement from the trim position. Again, the pilot has much more authority using the manual system. With the 3-axis controller, the pitch channel, like the other 2 stab-aug channels, can be engaged or disengaged independently. The important thing to remember is that the stab-aug system only adds to the stability of the F-4, and the airplane can be flown without it. Flying it without stab-aug is the quickest way to troubleshoot a flight control problem. More about that later. The F-4 Autopilot controls the ailerons, spoilers, rudder, and stabilator through the automatic flight control system to maintain altitude or attitude and heading. Heading in the F and ground track in the RF is maintained by the roll channel instead of the rudder. The rudder is used to damp yaw oscillations and help coordinate turns. Autopilot roll attitude control is maintained until the pilot commands roll. Then, just as in stab-aug, when the lateral force switch is made, the roll channel of the AFCS turns off. When the airplane rolls through 70 degrees of bank, all autopilot functions are turned off, even though the switch stays on. When the bank angle drops below 70 degrees, all autopilot functions are regained. When pilot command is removed, the autopilot reverts to attitude hold if the bank angle is greater than approximately 5 degrees, or to heading hold if the bank angle is less than 5 degrees. When the controls are released within 5 degrees of level, a roll to level accessory on the autopilot returns the airplane to level and maintains heading. The pilot may deactivate this feature by using the nose gear steering button. Autopilot pitch control is maintained until the pitch attitude exceeds plus or minus 70 degrees, or until the load factor increases beyond plus 4 Gs or minus 1 G. When the pitch attitude drops through 70 degrees, the autopilot will re-engage unless the G limits are exceeded. Within the 70-degree pitch range, corrections to the pitch attitude are made simply by pushing or pulling the control stick. The stick force transducer location, below the stick grip, senses the direction of applied force and commands the AFCS. When the desired attitude is reached and pilot input is removed, the autopilot takes over and maintains the new pitch attitude. At 4 Gs or minus 1 G, a G limiter turns off the autopilot to prevent an autopilot malfunction from overstressing the aircraft. This cutoff will show on the telepanel, and if the autopilot is used again, it must be re-engaged. Another autopilot accessory is the auto pitch trim system. Like the manual trim system, it automatically trims out forces in the longitudinal control system when the autopilot is in operation. If the out-of-trim stick force exceeds 5 pounds, the pitch trim light will illuminate. If this happens, the pilot can expect a pitch transient when the autopilot is disengaged. As for unusual autopilot characteristics, one is an occasional mild pitch oscillation between approximately 0.9 and 1.2 indicated Mach number. F-4 pilots learn to expect these minor pitch oscillations in this transonic region. What might be called an idiosyncrasy of the stab-AUG system is a 3-axis transient reaction to a loss and resumption of all AC power. This reaction is no problem for the pilot under comfortable flight conditions. Now that we've outlined the operation of the flight control system and pointed out a couple of characteristics, let's take a look at malfunctions. In the basic flight control system, friction is the #1 problem. High friction makes it difficult to make small, precise control inputs which would keep the airplane in trim. You can check the friction of the longitudinal system with 5-pound bob weights by setting trim for takeoff. Then pull the stick full aft. Release stick and it should go forward, at least to neutral. With 3-pound bob weights, the stick may not go forward by itself, so ease the stick forward, checking for excessive friction. If there is a noticeable decrease in the force required to move the stick, accompanied by constant nose-down force, a bellows problem may be to blame. Blockage of the bellows inlet with ice or other foreign material can cause this field system failure. Under these conditions, trimming nose up is not recommended because the force the pilot feels may be the bob weight, and it cannot be trimmed out. If the aircraft is trimmed nose up and the inlet clears, a healthy nose-up pitch change will result. So the trim should be left in neutral on the trim indicator. Difficulty in trimming the lateral control system generally can be traced to rigging problems in the system. Rigging problems also may cause roll fight or slight kicks in the stick when the pilot starts a roll with stab-AUG or autopilot on. Stab-AUG problems in the F-4, such as random oscillations or inputs, can only be eliminated in flight by turning off the stab-AUG. In fact, this is the first procedure to follow when encountering control problems. Eliminate the stab-AUG and work from there. However, this check should not be made at low altitude. If desired, individual channels can be selected by the pilot to determine which has a malfunction. With the authority of the stab-AUG limited to 1/2 degree of stabilator movement, 7 1/2 degrees of aileron movement, 11 degrees of spoiler movement, and 5 degrees of rudder deflection, any stray inputs can be overcome by the pilot. As for autopilot malfunctions, roll problems can often be cured by retrimming the basic airplane. This goes for roll reversal, when a slight lateral movement of the stick causes the aircraft to roll in the opposite direction, Roll fighting, when an opposite lateral force on the stick seems to fight or oppose the pilot's input. And roll rebound, when the pilot stops the roll at a desired bank angle and the angle decreases to a lower value as the bank attitude is captured. Sluggish roll to level reaction in the autopilot also can often be traced to faulty trimming of the basic airplane. If any of these conditions are encountered, the basic control system should be retrimmed. A yaw string should be used for directional trim if available. However, if the basic aircraft is difficult to trim laterally, the odds are high that a lateral rigging problem exists, which can only be corrected on the ground. If the lateral AFCS problem still exists after retrimming, the prime culprit is the lateral force switch that cuts out the AFCS roll channel. If the force required to move the stick laterally is lower than the setting on the force switch, the AFCS will fight you in roll. Any longitudinal pitch oscillations on autopilot above or below the approximate 0.9 to 1.2 indicated Mach number range are totally unacceptable. If there's time, the pilot can try altitude hold and see if the oscillations continue. At times, they will appear only in the altitude hold mode. Another check in all models except the E and RF is to disengage the autopilot. Turn off the static pressure compensator, re-engage the autopilot, and see if the oscillations disappear or diminish. When pitch oscillations are encountered, the pilot can do a favor for the troubleshooters on the ground by noting the altitude and airspeed at which they occur. If time allows, it also helps to know if the oscillations get worse, remain the same, or slowly go away. And if possible, he can time the cycles per second. The most common oscillation is 1 cycle per second from the highest point the nose reaches until it comes back to its highest position again. Roll oscillations can be caused by either the compass system or AFCS. Cycle the heading hold cutout switch to eliminate the compass input. If the roll oscillation remains, it is the AFCS. If it disappears, it is in the steering signal. When flying an F model on autopilot, a mismatch between the airplane attitude and the attitude director indicator can often be solved by switching from primary to standby attitude reference. In the F models, the ADI will display the AGB-7 gyro in standby. The autopilot always looks at the AJB-7. If the ADI and the aircraft attitude then match, the original mismatch problem is in the gyros and not the autopilot. This may save a day's worth of maintenance on the autopilot. In the RFs, the inertial navigation set is the attitude reference system for the autopilot. There are some basic ground checks for the F-4 flight control system. In the basic system, as with any airplane, the pilot cycles the controls using the mirrors or ground crew to make sure he's getting corresponding surface movement. The friction check of the longitudinal system can be made, as previously discussed, based on the type of bob weights installed. As for stab-aug ground checks, just turn on the system and have the ground crew check for abnormal surface movement. Ground checking the autopilot starts, obviously, with turning it on, while holding the stick in neutral by grasping it below the grip. If no sudden stick action results, the autopilot probably is functioning normally. If sufficient longitudinal stick force is applied to the grip to start the stick moving, it may tend to run to the stop. This is quite normal. The next step is to make sure the autopilot can be turned off. Another check can be made of the altitude hold mode after turning the autopilot back on. The first step is to engage it, then move the stick in an attempt to override it. If this stick movement disengages the altitude hold switch, the system is working properly. Another ground check can be made of the emergency disconnect switch. Just use it to make sure it will turn off the autopilot. There are other intricate autopilot ground checks, but they're difficult to make accurately and should be performed by autopilot technicians. In summary, F-4 pilots should become familiar with the basic airplane by flying it with no autopilot and no stab AUG. Then, when a control problem comes along, they can go to the basic airplane before trying to track down the problem. The pilots, and especially their crews on the ground, will be glad they did.